Welcome to this comprehensive beginner's guide, where we will embark on an exciting journey into the fundamental concepts of C# entities, components, and systems, collectively known as ECS. This powerful architectural pattern forms the very core of Unity's innovative data-oriented technology stack, or DOTS, which is specifically designed to revolutionize game development performance and scalability. Unity DOTS represents a significant leap forward in game development, offering a powerful and integrated collection of technologies. Its primary goal is to enable the creation of exceptionally high-performance games by fundamentally optimizing how data is structured, processed, and accessed within your game's architecture, leading to unprecedented efficiency gains and smoother gameplay experiences. The robust DOTS ecosystem is meticulously comprised of three key pillars that work in perfect synergy: the Entity Component System, which we'll explore in depth today, the Job System for efficient parallel task execution, and the Burst Compiler for highly optimized native code generation. These components are designed to work in concert, dramatically enhancing overall game efficiency, responsiveness, and scalability. While the broader DOTS framework encompasses several advanced technologies, this video will dedicate its primary focus specifically to the Entity Component System, or ECS. ECS is not merely a feature. It's a fundamental architectural pattern that underpins the entire DOTS philosophy, providing a revolutionary new way to think about game object design and interaction. ECS introduces a distinct, highly optimized, and data-centric approach to structuring your game code, moving away from traditional object-oriented hierarchies. This innovative methodology consistently leads to significantly better performance, particularly evident when your game needs to efficiently manage, update, and render a vast number of interactive game objects simultaneously, ensuring a fluid user experience. At the very heart of the ECS architecture are entities, which are essentially lightweight identifiers or simple, empty containers. They serve as the foundational, atomic elements, representing a single thing in your game world, such as a character, a projectile, an environmental object, or even an abstract concept. It's crucial to grasp that, unlike the heavy, feature-rich game objects you might be familiar with from traditional Unity development, entities on their own possess absolutely no inherent functionality, descriptive properties, or behaviors. They are purely abstract concepts, devoid of any intrinsic data or logic. You can think of entities as analogous to empty boxes or unique identification tags, similar to a primary key in a database. Their singular and exclusive purpose is to act as a reference point, designed solely to link and group various data-holding components together, forming a complete and functional game object definition. This is a critical distinction that sets ECS apart. Entities themselves do not store any data. Instead, their primary purpose is to provide a unique, lightweight reference or handle that points to a specific collection of components. It is within these components that all the actual, meaningful data for that entity resides. In essence, entities can be considered DOTS's highly optimized and streamlined equivalent to Unity's traditional game objects. However, they are intentionally stripped down, bare-bones versions, rigorously lacking the default components, layers, tags, and other inherent overhead that game objects typically include. This minimalist design makes them incredibly efficient and performant for large-scale simulations. For a beginner, a helpful mental model to adopt is to think of entities simply as unique identifiers or keys for your game objects within the DOTS framework. They are the who, or what, that possesses certain characteristics, with those characteristics being entirely defined by their attached components, rather than being self-contained. Moving on to components, these are the true, specialized data containers within the ECS architecture. Each component is singularly responsible for holding a specific piece of necessary information or a particular characteristic for an entity, making them highly specialized and focused on a single type of data. Components are meticulously designed to store raw data exclusively, such as an entity's current health value, its precise position in the game world using a vector 3, or its movement speed as a float. Crucially, they contain absolutely no operational logic, methods, or behaviors. They are pure, inert data structures, ensuring data integrity and cache efficiency. To achieve optimal performance and memory efficiency, components in Unity dots are typically implemented as C# structs. Structs are value types, meaning they are stored directly in memory rather than on the heap, and are passed by value. This design significantly reduces garbage collection overhead and improves data cache locality, which is vital for performance. A single entity can have multiple, distinct components attached to it simultaneously, forming a unique combination of data. This fundamental design principle allows for an incredibly flexible and modular approach to defining your game objects, enabling rich and varied combinations of characteristics without complex inheritance hierarchies. Consider a practical example to solidify this concept: an Orc Warrior entity. This single entity wouldn't be a monolithic class, but rather composed of several specialized components. It might have a health component to track its hit points, an attack component defining its offensive capabilities like damage and range, and a movement component dictating its speed and pathfinding behavior. This inherent modularity is a significant advantage of ECS, as it allows for easy modification and highly efficient reuse of specific data structures. For instance, the same movement component could be attached to an orc, a goblin, a player character, or even a non-player vehicle, promoting extensive code reusability and reducing duplication. A crucial tip for working with components effectively is to always strive to keep them as small and focused as possible, dedicated solely to storing data. Rigorously avoid embedding any operational logic, methods, or behaviors within your components to maintain their purity, maximize cache efficiency, and ensure clear separation of concerns. If entities are the what and components are the data, then systems are definitively the how. Systems are where all the operational logic and behavior resides. Defining precisely how entities and their attached components interact, evolve, and behave within the dynamic environment of your game world over time. Systems are designed to be highly efficient and targeted processors. They perform specific actions or operations exclusively on entities that possess particular, predefined combinations of components. This allows for highly targeted data processing, ensuring that only relevant entities are considered for a given operation, optimizing performance. The core function of a system is to actively utilize and interpret the raw data stored within the components of relevant entities. By reading, processing, and manipulating this data, systems effectively determine and enact the behavior, state changes, and complex interactions of those entities over time, driving the game's simulation. To illustrate this with our Orc Warrior example, an attack system would be responsible for processing all entities with an attack component. It would read the data from this component, such as attack range, damage values, and attack speed, to calculate the orc's effective attack output and determine if a target is within striking distance, then apply damage. One of the most powerful and performance-enhancing aspects of DOTS is that systems can be executed in parallel, leveraging Unity's highly optimized job system. This capability significantly boosts performance, especially for complex operations involving many entities, by efficiently distributing workloads across multiple CPU cores simultaneously, maximizing hardware utilization. This inherent ability for parallel processing is absolutely crucial for efficiently handling and updating truly massive numbers of entities, which is a common requirement in modern, data-intensive, high-performance games. It prevents bottlenecks and ensures the game maintains smooth frame rates and responsiveness, even under heavy load. A helpful and critical tip for designing effective systems is to always strive to process data as efficiently as possible. This means minimizing any unnecessary overhead, performing only the essential calculations, and ensuring your queries for components are highly optimized to avoid redundant work and maximize throughput. Now that we've covered the fundamental building blocks of ECS, let's take a moment to briefly contrast this innovative architectural pattern with a more traditional object-oriented programming, or OOP, approach commonly employed in conventional game development. In the traditional OOP paradigm, data and the logic that operates on that data are typically tightly encapsulated and bundled together within single, monolithic objects. While intuitive for small projects, this can sometimes lead to inefficient memory access patterns, cache misses, and significant performance bottlenecks, especially when dealing with a large number of similar objects. ECS, however, takes a fundamentally different and more performant approach by distinctly separating these concerns. Raw data is isolated into lightweight components, and the operational logic is centralized within specialized systems. This clear division is a cornerstone of its efficiency. This deliberate and strict separation of data and logic in ECS allows for much better data-oriented optimization, enabling highly efficient memory layouts and superior cache utilization. Furthermore, it inherently facilitates parallel processing across multiple CPU cores, which is a core and powerful advantage of the entire DOTS framework, leading to massive performance gains. By leveraging the highly optimized and data-centric ECS architecture, DOTS effectively avoids many of the performance drawbacks, scalability challenges, and memory inefficiencies often associated with traditional object-oriented programming when dealing with Unity's game objects. It offers a more robust and performant solution for complex, data-heavy games. For beginners just starting their journey with DOTS, it's highly advisable to begin by implementing very simple systems and components. This gradual, step-by-step approach will help you grasp the core concepts and internalize the data-oriented mindset without being overwhelmed by excessive complexity or advanced features. Always make sure to fully utilize the Burst compiler, a powerful and integral tool within DOTS, which automatically translates your C# code into highly optimized, high-performance native machine code. This compilation happens at runtime, providing significant speedups and performance improvements without requiring manual low-level optimization efforts. To truly unlock the full performance potential of DOTS, it is essential to leverage the job system. This powerful feature allows you to run your systems and other heavy computations in parallel across multiple CPU cores, maximizing throughput and ensuring your game remains responsive and fluid even with the most complex simulations and large entity counts. As DOTS is a rapidly evolving technology, it is paramount to always refer to Unity's official documentation and the provided example projects. These resources offer the most accurate, comprehensive, and up-to-date information, along with practical best practices, which are invaluable for both learning and effectively troubleshooting your DOTS projects. Remember that mastering ECS is an iterative and continuous process. Continuously iterate and refine your ECS code over time as you gain more practical experience and a deeper understanding of its underlying principles. Always seek to improve efficiency, clarity, and maintainability, adapting your approach as your knowledge grows. Don't feel pressured to convert your entire existing project to DOTS immediately. Often, a pragmatic hybrid approach, combining DOTS for performance-critical sections with traditional Unity methods for other parts, is the most effective and manageable strategy for many projects, allowing you to gradually integrate DOTS benefits where they matter most. Finally, it's crucial to understand that while incredibly powerful and efficient, DOTS is not always the absolute best or most appropriate solution for every single project. Always critically evaluate your project's specific needs, constraints, and development timeline, and choose the right tool for the job, whether it's pure DOTS, traditional OOP, or a thoughtful hybrid approach. Thank you for joining us in this comprehensive introduction to C# entities, components, and systems within Unity's powerful DOTS framework. We sincerely hope this guide has provided you with a solid foundational understanding and sparked your interest in exploring the exciting world of high-performance, data-oriented game development.